This is project 4, video number 2, the one in which we coded up. So let's hit the edit, go to the editor. Make it so that you can see it. And let's see what we want to do here. Start with a function statement. And then we're returning nothing. So I'll call the return variable dummy. And then plot. Go lambda and phi. Plot lambda and phi of a comma b. And if b not equals 0, disp b not equal to 0 results in singularity. Setting b equal to 0. If so I don't really actually have to set b equals 0, but mathematically we are setting b is equal to 0 by ignoring it in our expressions. Else, and then this is an AND for the if statement. So with the else, this is where we actually do stuff. Oh, we got to do stuff no matter what, so we don't need an else. Just end. Alright, now we actually do it. A cool equals a times 1e minus 6. K equals 8.99 E9. L equals minus 0.25. U equals 0.25. So this, the code as it is, it's just always going to give 0, but if somebody wants to modify this code, for phi, if somebody wants to modify this code where maybe one of the changes is just the upper limits and the lower limits change, we'll have something all set up for them to go, even though what we actually produce is just going to be generating 0 all the time for phi. But we still have to graph the lambda, so it's not like it's not going to do anything at all. And then What else do we have? I think I'll go y min and y max. So these are actually, and you can change names. I'm going to call that x min. Oh, that's x prime min. So it's better just leave it as a lower limit. That gets too long. X prime and min. So let's keep that like that. So x equals linspace from L comma U, and that's actually x prime, and I'll have 100 values in there. That's I think we need 2 to get it, because it's going to be a straight line, but again, we haven't set up for in case somebody wants to change the function a little bit. Okay, and then the y values equals linspace of y min comma y max comma 100. What else do we have? Let's go to my paint and see what else I wanted to do here. So I gotta find the code. Tell the usage should be equal to 0. Get A and B from the users. Yeah, treating it as if it were 0. X prime equal y. Linspace, I got both of those. A coulombs. I said times 1 times 10 to the minus 6, and it said divided by 1e6. That's the same thing. So I think I'm ready to type in phi already. So phi equals K times A coulomb times, I believe it's capital U, no, square root, capital U squared minus y squared minus, and then the same thing, but I go Control C, Control V, close those parentheses, but I gotta change that to a lower. Upper squared minus y squared. Let's see, actually I have L first, and then minus that. I think that's a mistake. So yeah, this is the upper minus the lower. So let's fix that. So hopefully you code stuff up before you do the whole pencil and paper part. Yeah, before you turn it in, so you see this video before you do that, or you notice the mistake yourself and fix it. Okay. So where was I in oh, I needed to do the lambda. I was supposed to switch the order of these. Lambda equals times x prime. And then it would be plus b, except we're treating b as if it was equal to 0. So that's in the sense in which I'm setting b is equal to 0, even though I don't change it in the code. Okay, then try. Alright, this is where I think I'm going to use trial and error. It's something like create, here, maybe, no, it's not telling me what I need to know. I think it's 1 by 2 region and go in region 1. So 1 by 2 region, and that means there are only 2 boxes on the page, and I'm going in the first box. So that's I think 1 row. No, I believe I'm going to go 2, 1. 2 rows of 1 element each, and then get in the very first box and plot lambda, so it's x prime comma lambda, and then subplot 2 comma 1 comma 2, the second box, plot y comma phi. If we did it right, the ladder plot should just be all zeros. Alrighty. I'm going to try to delete right there. That would print out a bunch of numbers. These, I don't think these print anything out. So let's try saving it as plot lambda n comma phi. I think I'm going to Control C. Alright, save that. And I gotta get in a good directory for this. Alright, and then I can save it. And then I want to go to the MATLAB window and try running it. 2 comma 0. I'm going to switch to the right directory over here. Okay, projects, where are you? Try that again. Unexpected MATLAB operator in line 2, column 12. Ooh, if B. I think I typed in an O instead of a Control S instead of a 0. Alright. Still doesn't like it. Column 12. Which column am I in? 17. 12 is right there, so apparently that's not how you do the not equal. So, gonna try less than, greater than. I don't think that's it though. So I'm gonna have to try help if so they give some examples there. Oh, squiggle equal. There it is. So go back to the editor. Squiggle equal. So let's try that. Tilde equals Control S. Try running it again. Excellent. We got much farther along. So the old trying to do something with an array, I want to do it on an element by element basis. Whatever the operator is, I put a dot in front of it. So I have y dot squared instead, y dot squared instead of just y squared. And I think that should do it. It's worth a try anyway. So it's a little bit funny. We're just trying to get it to evaluate to 0. That's where the issue is. Alright. Looks like I do have a function lambda. It's supposed to be a times x. I chose 2 times 10 to the minus 6. So at for a I chose this 2, and it's microcoulomb, so 2 times 10 to the minus 6. And at x is equal to minus 0.25 for instance, that should be minus 0.5 times 10 to the minus 6. So I think I got an issue there. Probably used a instead of a coulomb. Yeah. I need to use the cool A, not just A. And then let's see what that error was too. So we can fix that and make the figure go away. A subplot looks like a spelling error. Subplot, sublot. It's a word, but it's not what I want. Control S. Try running that baby again. And I've got, I don't think I showed you that before, so this looks good. Minus 5, that's times 10 to the minus 7th. Yeah, 2 times 0.25 is 0.5, so 0.5 times 10 to the minus 6, and 5 times 10 to the minus 7th. That's just another way of writing it. Oddly enough, this one, it's got the wrong range of values. Seems like it should be from minus 0.25 up to 0.25, and then it doesn't have phi going across. So you know, I would expect a horizontal line at the 0. It chose what the limits would be, but no horizontal line there. So something is not right. out what U is. I must have forgotten the semicolon. There we go. Fix that. Plot Y, comma phi. Oh, I went 0 to 0. So remember that was supposed to be minus 0.25 to 0.25 as well. I'll call that a coincidence. It's just the way it was given. Let's try that. Control S. Up arrow. Alright. Looks perfect. Everything looks perfect. I think we kind of lucked out, and I actually see that 0 line. I thought it would be right along the bottom edge of the page. It automatically chose these units, these values, minus 1 to 1. Remember the other one went minus 1 to 1, I think, so I guess that's the default set. But now the x-axis has the appropriate value. It's supposed to be minus 0.25 meters up to 0.25 meters, and then these are arbitrary. So I got to do things like title the plot and whatnot, but this seems to be working. So yeah, the second plot is boring. It's an awful lot of work to have just a 0 line, but I think it's appropriate. Note if somebody changed this, say to 0 for instance, then I would expect something non-zero. Let's do it even though it's got to change it back because it wasn't called for. So yeah, there it does get a lot more interesting. So in other words, the charge to the left of 0 is 0, and so the charge distribution only extends from the origin out to the right. Our function, yeah, this is the actual distribution with BBN equal to 0, and we see, I think that's kind of interesting. That Y is equal to 0. Now we can't handle it because the charge is 0, so nothing's blowing up there. So as you go higher and higher up on the y-axis, the potential increases for a while, and then it starts decreasing. So that's kind of interesting. On the other hand, it's above and beyond what was called for. So this was minus 0.25. It was, let's make sure it works still. Oh, again. So I got nothing extra being printed to the screen, nothing at all in fact. And get lambda versus x and phi versus y. And I think they both look right. So it could be useful to somebody, but they are going to have to, they would have to have a different agenda than us. Maybe that would be different, or maybe they want to graph it anyway. But they've got something that they can start with to modify. They might have to add on that natural log part if they want to use b being equal to something other than 0, but if they did that, then they would have to change the plot region to exclude y is equal to 0. Go from minus 25 centimeters to minus 5 centimeters, and then 5 centimeters to 25 centimeters, something like that. I guess the one thing I wanted to check is, do I alert the user as to what's going on if somebody types in some b value other than 0. So So b not equal to 0 results in singularity, setting b equal to 0. I think that's good. It says something about don't have it print anything to the screen that it's not supposed to. Well, as far as I'm concerned, it should print that. And the other thing is, in here, I can tell the reader, you know, explain function. You might want to mention it will be 0 in here. Remember, this is you know, all your words. Don't just be copying what I'm writing right now. Explain the function. You know, say what it does. You might mention that it's going to be 0 for all values of y on minus 25 centimeters to 25 centimeters. Alert them not to be surprised. And also don't use b equal to 0 because that results in a singularity at y equals 0. We're supposed to be graphing right through y is equal to 0, so we won't be able to plot it. You know, it's a divide by 0 situation. Alright, let's just make sure I didn't mess anything up. Just type it in comments. It happens, believe it or not. And I keep on typing in the same value of a. So let's make sure it works with a different value of a. And you got 7 times a quarter. That's just a little under 2. Well, in magnitude. So it's minus a value that's just a little under 2. And yeah, and then this goes up to a point, you know, 7 halves. No, 7 times 0.25, which is 7 quarters, which is 1 3/4. So I think that looks reasonable. I'm not sure it's perfect. It looks perfect, but it looks reasonable. So I'm going to call that a wrap for Project 4 Video 2.